Hello everybody, we have 8 p.m. Central European time. As I said, I want to fight a little bit the Corona boredom. So I welcome you to some insights of TripleR, robust rescue rigging. This is my system. At first I have to claim a conflict of interest. Due to stupid German laws, I have to claim this at advertisement as I name preferred gear, which I sometimes got sponsored, and I promote myself. So if you don't like advertisement, you should stop watching this video, go and grab a book and read a little bit. I have to tell you about a disclaimer as well. The presented paper is intended to document techniques for rope-based rescue. It is published to initiate a discussion base for a cross-organization exchange of methods. All shown techniques have been tested, validated and documented on the basis of up-to-date realistic risk assessment. At the time of publication, the methods are regarded to be safe approaches, including redundancy. Before implementing these systems or parts thereof as a user, you must verify their safe applicability on the basis of your own independent risk assessment. Please consult the user instructions of all used gear and devices when conducting your risk assessment. Rope techniques for access and rescue put high demands on the user. Even smallest errors can have drastic or even fatal consequences for you and others. Extensive and continuing repetitive training is mandatory. By using the presented illustrations, you personally accept the implied risks, responsibilities and liabilities. The usage of this material takes place at your sole discretion and responsibility. The author takes no liability for any damage, injury or fatality resulting from application of any part of the presented methods. If you do not feel comfortable or proficient with these methods, or if you are unwilling to take full responsibility for their application, you must refrain from using them. Okay, so this is for the lawyers. I want to tell about my system, and my system is risen in the sweat. Risen in the sweat for more than 33 rope rescue courses as a lead instructor. On every course you learn something and see a new opportunity or get something back from your trainings. It's an interdisciplinary collection of the best practice methods. So from IRATA I took off the alpine butterfly, or from mountain rescue I got the twin tensioned mirrored systems and the spider anchors, and it's risen in the sweat by traveling worldwide to rope rescue competitions to get proven by others. So it's about more than 17 international rope rescue challenges. Like 2008 when we had been in Poland, so greetings to all my Polish friends. I joined as a team leader 4 times with German nationals. I had been 8 times team leader at Crimp Day. Greetings to all my Belgian friends. I had been 1 time a controller at Crimp Day. I joined several times rope and rescue in Belgium, also a very physical challenge. I had been 2 times in Chao in Taiwan, so greetings to Jay, Simon and all my Taiwanese friends. We had been 1 time at Lifeline China, also a very interesting competition, and 1 time at Crimp NA in North America. So greetings to all North American friends as well. Robust rescue rigging. What does it mean for me? It means it will be a reliable system when it's cold, when you're frozen, when it's hot and your head is boiling, or when you are exhausting. So it doesn't count if you can make a setup on your best day. It counts that you can build your setup on your worst day. For me, you can make this when a system is based upon similarities and repetitions. This is very important. So you will have the similarities again and again. I can tell you many approaches are possible. This is my approach, but if you have another approach, I respect that as well, and it's fine. I can tell you, don't search for the best system. Search for the one with the fewest limitations. This is a shout out and a quote from Sascha Köhler. He's a former CIC instructor. I have to state, the best system is the system you are well trained in. As I told you, in respect of many competitions, for me, competitions are not about a rank. They are a proof of concept. Let your system proved by others and have a look about your performance. If you arrange your own training, you don't see any news, or you have just in mind in the making of a training how you would solve it with your own system. So there's no way to improve that. But if you go to a competition and let you prove by the tasks others give you, you really improve your system. And please don't judge a last place at a competition, because this team exposed themselves to others to improve. So this is a very high aim, and we have to respect and honor this aim. Robust rescue rigging is a system based on attendant stretcher rescue. Downsizing to a rescue triangle or something like that, that is easy. But updating from just a rescue triangle to a stretcher is very hard. The attendant should have their hands free and as less workload as possible, because he has to care about the casualty, like ventilating or stretcher handling. So if he has to operate too much, he can't communicate or he couldn't ventilate somebody. So my main focus is that the rescuer is attached at the stretcher, and I don't like these techniques like parallel climber. There are special cases. So if getting the attendant to the system takes more time than just lowering without the attendant, or if the environment doesn't allow an attendant. It's like cave rescue. So maybe if you are just on a free floor building and getting the attendant over the edge will take more time than just lowering the stretcher with a guideline, so please make this. But if you're going higher, then you should have an attendant on your stretcher, especially for psychical and mental health care, and like ventilating or stretcher handling. Robust rescue rigging is also a passive system, so means mainly lowering or rising from a team above, and where attendant should have less workload. Robust rescue rigging is obeying the demands of having redundancy. We have some laws here in Germany, and they are telling us in the case of work we have to have a redundancy, and so we are doing a critical waypoint analysis in each part, and it must state if one thing will fail, we will have no fatality. Robust rescue rigging is made for urban and rural environment. This is not made for tug rescue. It's not military climbing and military rescue. It's not alpine or backcountry rescue, and it's not cave rescue. If you search for one of those 4 fields of applications, other systems will be more appropriate. I have to say a big thanks to my mentor Harald Straub, because from the beginning, from the first day, he taught me about mirrored systems. So this is an old instruction manual from him, and he taught me the mirrored system by a carabiner brake. This is a technique which got nearly lost these days, but it's very simple, and since the time back in those days, he taught me mirrored systems, and I keep that mirrored systems from the beginning. And he taught me about a focal point. A focal point means that all these ropes from a lowering system come together to a focal point and are divided again. So this is one rope, one lowering rope, the second lowering rope. They are equally loaded. They come together on a focal point and share the load again, maybe to a casualty and to a rescue. And I added bypasses, so to get a little bit more redundancy in the system. To make it that you can imagine that better, I made this drawing for you. So both ropes come together to a rigging plate, and the fours are divided again, and we have these bypasses. He taught me as well, a master's aim is to build compact systems. Because if you have that, it's way less exhausting to get a stretcher over an edge without an artificial high direction. And so if you want to train in a robust manner, you should search for compact systems. On my approach of the system, I did read many books, and one of those books is the High Ankle Rescue Techniques from Tom Vines and Steve Hudson. And in that book, I did found this drawing about the interlocking long-tail bowline as a focal point. I really did like this idea because they bring both ropes together and share the force again. But actually, in this book, this is a German book, there are many accident reports in that book. They state that we shouldn't use the bowline because back in the days, in November 1965, we had an accident on a mountain rescue training where the bowline as the anchor point did fail. In these books, they state if you loaded the bowline by the tail, nothing will happen. But if you made a ring load, it just opens itself. This book shows several accidents back in the days, tying in directly. For competition climbers as well, the last point has been in 1992. There was a big accident. So that leads to the part where the bowline is nearly prohibited, or not prohibited, is not accepted in Germany for that part. If we have to take our risk assessment and something is stated in a book and we don't keep that into account, maybe we make our risk assessment not in a good way. So in 2007, searching for my system, I was taught the Alpine Butterfly by Damien Napier while spotting an IRATA course, and this Alpine Butterfly did fascinate me. I didn't know it not before, and he showed it to me, and that you can load it in any direction. So I thought this will be the perfect knot for this focal point. This was our early version of a focal point, but we had problems because this setup is prone to cross-loading, especially while lifting. If you lift the system and both lines are not lifted equally, one strand gets unloaded and the weight of a rope turns the biner in a rigging plate. So this is a cross-loaded part, or sometimes the gate gets into this hole, so this is more dangerous. So this is prone to cross-loading, and I don't like that because this is not clean rigging for me. So our first improvement was clipping both biners into both butterflies. So even if one rope gets unloaded, the other rope holds the biner in the position and it's less prone to cross-loading. But you know, we are on an approach for a more compact system. On this system, we lose the height of a rigging plate and the carabiner. So we wanted to save that height. And the big Alpine Butterfly offers a great solution for us. So we just take two ropes and make the butterfly knot with two ropes, so we're getting the big Alpine Butterfly. And here you see the system headspace is from the floor of the stretcher to the upper side of a knot. And the question is, how long is that? A very long part is hard to get over an edge, and as shorter it is, as easier the edge management is. So you can see this here on a crimp day picture as well. We didn't got a very high direction and had to go over this edge with an undercut. So a short system is mandatory, and you see it's just our bridle length, one biner and a small butterfly. So with these basic ideas, we come to basic setups of TripleR system. The first part is a pick-off rescue. Our attendant is made in a flexible way to the system. He can move with a red system, so mainly he uses a small grillon, a 5-meter grillon. He can descend a little bit or add a hand descender and a pulley and can go back, and he is fixed with a redundancy by a bypass. This is again the big Alpine Butterfly, and here we clip a shorter grillon for the casualty and the redundancy for the casualty. I like flexible connections to the casualty because if you get lowered and you can adjust yourself and you can adjust the length. It's way easier to communicate with your lowering team. And especially if you have suicidal persons, you can lower suicidal persons below your feet, so they can't reach you because they are in a big stress and you don't know how they react. So I like to lower suicidal persons below my feet. Otherwise, if you have a normal casualty, it's easy for pick-off, because if you have some room and space to bring the rescue triangle or the pick-off sling to a casualty, you have some space and room where you can work. I want to provide the lift by the team upstairs. So on both ropes, we just have to set a 3-to-1 on each rope, and after getting the casualty and to my rescue triangle, I just call them that they should provide lift and I get them out. I made a pick-off rescue on a wind turbine when 70 meters of rope have been above us, and if you think you can make this with a short 4-to-1, I can tell you, you won't get out the stretch of the system. In that case, I just clip him. The rescue has just the workload of clipping the rescue triangle and the redundancy, and the lift will be provided by the team. So we should have less workload on rescuer. We should share the workload to the whole team. From pick-off rescue to a stretcher rescue, we just have to change the grillon. We bring a stretcher in and take the grillon out. The beaners from the big alpine butterfly to the stretchers are doubled and opposed, as they are highly exposed to edge and surface contact while edge transfer. So here on that point between our big alpine butterfly and the stretcher, we use 2 beaners doubled and opposed. So the big part is stay in the system. Do you see the similarities? Big alpine butterfly, red system, backup, a short connection to casualty, and a bypass. And we just take this grillon out and take a stretcher in. So this is the way from pick-off rescue to stretcher rescue. Stay in the system. If we want to make offset deflection out of that, we just add 2 ropes, connect 2 ropes together and place pulleys here. Here I think there's an important part. If you have open able pulleys, they should be placed opposed, and the opening ledge should be orientated every time outside. We call this a little bit more Y system because it's like an Y. Stay in the system. From vertical stretcher rescue to steep highline, we add only to this system 2 main lines, a couple of beaners, a Courtney and an ad stack. It's just the point between here and the stretcher which changes from the vertical stretcher rescue. I want to give you some insights in our steep highline rescue. At first, I need a part to equalize stretcher movement with a swivel. So we place the ad stack here. With that ad stack we can lift the stretcher into the system, and the ad stack has two swivels, so we equalize all movements of rotating the stretcher. You can see it in these pictures, and when I observe trainings or something like that, I see it often that stretchers are turning or be pushed by a rescuer in a bad position, and if we have no part which equalize the movement, we turn our pulley sideways and the side plates of the pulley will meet the rope. The side plates can get grinded by rope movement up to a sharp edge, and I think there's a possibility if a sharp edge gets grinded by ropes inside here, that these sharp edges can cut the rope. So if we have the ad stack here, we have two swivels, and you can turn around your stretcher and no movement will go up to your pulleys. Position for attendant during edge transfer. Back in the days 2013 at Crimp Day, when I had been controller for the Berlin team, I could see about 12 teams in a scenario going with a stretcher over an edge into a steep highline. And about half of the teams put their rescuer first and stretcher did follow. The problem was when they did put the rescuer first, they got the first sack on the rope on the main lines, and then they couldn't go with a stretcher over the edge. So I think this is not the best way to go with a casualty over the edge. The other half of the teams put the stretcher first and the attendant follows, and it was completely different. So I think this is a high evidence for a conclusion: stretcher first, attendant follows. We see it here again. We have not so much space here, but the stretcher is in the system. It was easy to get it out here, and the attendant climbs to the system as well. Another big part is that the lowering lines must be parallel to the main lines, especially over the edge. So these high directions should be very close to the directions of the main lines. If we don't do that, if we bring our lowering lines directly from this side, we pull with a big vector the main lines to the edge, and it's harder to get into the system with a stretcher. Why do we use a kootenai? We recognized that the kootenai offers the ability to ride over twisted ropes. On these competitions, we were forced for big distances. So if you have to build a steep highline with 80-meter distance, it's not that easy like in your training center, because managing ropes well, but we are not twisted over 80 meters is not that easy, and we wasted all times a lot of time for that. So when we were moving to a kootenai system, we had no problem riding over twisted ropes. So we just take rope ends, bring them to the other side, attach 2 ropes on the other side, 2 ropes on our side, tension the ropes and place the system, and can ride twisted ropes. Another big thing is that we back up every pulley axis. Also the pulley axis if they are 40 kilonewton axis. Why do we do that? Because I have 2 failure reports available when pulley axis failed due to construction or manufacturing issues. So in my risk assessment, I think it can happen and I have to take care about that. This position is not recommended with a bowline, because if this one will fail, then we will have a bigger ring load on a bowline, and as stated in the books, I don't like that. Again, stay in the system. Converting steep highline to a skate block. It's easy with that system. We just redirect the rope, and for our steep highline it was shown with 4 ropes, and if we want to convert it to a skate block, we just take this rope and redirect it high above our exit, and we are getting a skate block system. A skate block system, it's not my preferred system because it's very rope consuming. It takes about 2.3 times the height. So the rope you have to use is about 2.3 times the height if you control it from downstairs. And our normal rope length is about 100 meter rope. So we don't even have 50 meter operational height with a skate block, so this doesn't make a lot of sense for me, but it's easy and we stay in the system. Stay in the system from steep highline to transport highline. So we have a steep highline and bring it to transport highline. So we just unfold the system. We're going back from the big alpine butterfly to 2 single alpine butterflies. We just open the book, we just unfold the system. So these techniques, from pick-off rescue to vertical stretcher rescue to steep highline to transport highline, this is the core of TripleR system. Let's talk about advanced techniques. Advanced technique is like the mirrored English reef. So this was our standard since 2014, but it's ongoing to be replaced. The big advantage is that the attendant has hands-free. During all move, he don't have to place a backup, he don't have to operate anything, and it's easy to move sideways because the rope is resting on the reef. But this system is gear consuming and difficult rope handling during installation, even for a well-trained team. So on crimp day, I think with my team, we had been very fast on that, but we have to brought 5 ropes over the gorge. The French teams are way faster with their system because we have only to bring 3 ropes over the gorge. So bringing 5 ropes over the gorge, well managed, is really hard. Some insights in that system. the system offers just a small penetration depth because the required rope length on the reef is the horizontal distance plus 2 times the vertical distance. So with the 100-meter ropes you don't have big distance to cover. So normally you need very long ropes for lifting lines. This is our earlier setup. Again, we wanted to back up the axis of the kootenai, and we are using express sling, a short sling, but this spinner here is gravity orientated, and gravity did put it all times cross-loaded in the hole. So this was not so fine, and our solution was that we attach an open ring with one of those short slings permanently to our rigging plate and just put a spinner over there, and so we have a redundancy without any shock load. The reef V, it's like a V shape, should be as big as possible. If you just have a small opening of a V, it's prone to get blocked by rotation and friction. So if you go down, also the own rope twist leads to make the stretcher spin, and you will get blocked by the rotation and the friction by the twisted ropes. We had it in a 25-meter canyon, and we need a lot of force to get them back out. This is also a dichotomy between real world and training center heights. So if you do that just in your 12-meter training center heights, you don't even recognize this problem. But if you go out or in a competition and they force you to make this on 25 meters, it's completely different. So the reef V as big as possible. The conclusion for us was the white side of the rigging plate should be downward orientated, and the placement of the reef pulleys as far apart as possible. So the reef pulleys go into the outside holes, and the short slings for redundancy go to the inside, because on the inside they are well orientated by gravity. If you take these pulleys one hole more to the inside and this redundancy outside, they are prone to cross-loading, and you make your V more steeper, so that's not a fine part. So for me this is a part of clean rigging. As I said, we are ongoing to switch this system to a modified Norwegian reef. We have some specialties on this Norwegian reef. The first part is we have all times secured 8 knots in our ropes. But if we just clip an 8 knot onto that system, we lose a lot of head space. So the system height just got bigger. So normally we just clip the spinner to the pulley, clip in the loop of the 8 knot and place a cloth hitch behind. So we can go up with the system directly to the rope from the cloth hitch. A big part is to the far side. We just have to bring 3 ropes over the gorge. And why we modify this? Because with a clutch, if we want to go sideways, if we lower this rope and pull tension on that, the load just rests on the clutch. If we have a traditional Norwegian reef and we want to go sideways, we also have to lift the load again, because if we lower that side, the load will go down and we have to apply big forces here. So with our system, we just have to lower that side, pull this with a 3-to-1 and take in slack here, because the load rests on the clutch while being moved sideways. Actually, we only recommend this with a CMC clutch. We were working on this system for several years and did test it with other descenders, with traditional style descenders, and I can tell you we cracked 2 traditional style descenders. So actually I can only recommend it with a CMC clutch. We place here redundancy as well, so if something will happen here, that the system got caught as well. Again, we place this with open rings because we want to avoid cross-loading on this part. A little bit a special part is cross-hauling, and we wanted to make a cross-haul setup where these spinners are less prone to cross-loading. So we just take again our big alpine butterfly, placing them with 2 spinners doubled and opposed to our focal point, and using the tails, and the tails will be clipped into our ropes from the other side for cross-hauling. This system is easy to convert to cross-haul because we just have to unclip these 2 spinners and place 2 pulleys on that and bring the pulleys on this part. So I think you might see the similarities again and again. Now it's very important to have a look on the TripleR tactic chart and decision paths. I hear a lot of discussion, oh, this is useless and this is. So I want to have a look, when should I use which system? And I found an answer. I will use the transport highline if I have it to bring from my side to the far side. Just going over, lift it in here to the system, going over, bring it down. I will use the offset system or the Ypsilon system if I have a rectangular in a vertical orientation. So if I have to, if a deep penetration is needed, because this saves me a lot of rope, because from that part I can nearly use 100-meter ropes for this part, and I just have to control these sides. I have to pull it a little bit out for lowering, and after the lift I just have to lower this side, but it swings back to this part. On this part we made a comparison between the offset deflection system and the cross-haul system. For cross-hauling, going down, it's easy because we have only both sides to control to getting down. But if we want to go back up with a cross haul, we have to pull on both ropes, on both sides equally, and this is very force consuming. So I recommend cross hauling more if we have a rectangular part, so we can just go out on that side and swing the rope in. So if we are on that position, we bring some tension from that side, where the stretcher goes out. Then we lower this side and the rope swings to the place where we want to take him up, where we want to pick him up. And afterwards, we just pull back on that, so he swings again upstairs, and then we lower the other side a little bit. So if you can swing him, then this cross haul system makes sense. But if you have a deep shaft where you have to pull on both ropes, on both sides equally, it's very hard. And these parts you should use if we have a square part, or if we have a wider part where we want to go over with a horizontal line. So I think this is very important to understand when to choose which system. So this is the end of my basic insights of TripleR system. I want to say many thanks to Iterum, Steve Achelis, because he gave me the opportunity to use V-Rigger for all these drawings. I have a very good relation with several manufacturers like Austria Alpine, because I like their Binas pretty well. CMC for clutch descenders and my beloved Halo shirts. For Teufelberger, offering ropes for all our tests and worldwide traveling, and Colbride and Bunz about the roll-up stretchers. So this is the end. I'm below 1 hour. So thanks for watching. And if you are interested in more insights, please send me a message. If you want to learn some tricks how to get fast in rope rescue, I offer on-site courses, so you can book me to come to you. And so far, I wish that you all stay healthy. I can't say stay safe, because I know fighting fires, rope rescue and fighting Corona isn't safe. So I wish that you return home safely all the time. And a big shout out to all frontliners in the fight against Corona. Stay strong.